Okay, so what if our most powerful AIs could learn continuously, just like we do? Today, we're going to dig into this absolutely fascinating paper from Google Research that tackles one of the biggest roadblocks in AI. It's offering a potential cure for a kind of digital amnesia that has held these systems back for years.
So let's just start with a really surprising question. Why is it that these massive, incredibly powerful AI models we hear about every single day, the GPT-4s of the world, why do they basically have amnesia? They can use everything they learned in the past, but they literally can't form new, lasting memories.
And that right there, that's the crucial point. Once these models finish their huge, expensive training, they're essentially frozen in time. If you want to teach them something new, you can't just hand it a new book to read. Nope. You have to retrain the entire thing from scratch. And that doesn't just add new knowledge, it actually risks catastrophically destroying everything it already knew.
So here's our game plan for this explainer. First, we're going to really get a handle on AI's big memory problem. Then, we'll dive into the radical new solution they're proposing, nested learning. From there, we'll look at the awesome new tools this idea gives us, see it in action with an AI called Hope, and then finally, we'll zoom out and see what this all means for the future of truly intelligent machines.
All right, so first up, let's put a proper name to this AI amnesia. The technical term for it, and it's a great one, is catastrophic forgetting.
And you know what? It's pretty much exactly what it sounds like. When you try to teach a trained network a new task, say recognizing a new kind of bird, the new connections it forms can completely scramble the old ones that let it recognize, cats and dogs. The new knowledge just catastrophically overwrites the old. Poof, gone. And this just brilliantly shows how wild and unnatural this is compared to us. Our brains are absolute masters of continual learning, right? We integrate new facts, we consolidate memories while we sleep, and we adapt our entire lives. Current AI, it's just stuck with this static knowledge, forcing this incredibly expensive, all-or-nothing retraining process. So the big question is, how do we fix this? Well, the researchers argue we need to completely rethink how we build these models from the ground up. And this brings us to a brand new way of thinking, one that's actually inspired by our own brains, nested learning. The paper kicks off by challenging what they call the illusion of deep learning architectures. And the illusion is this idea that progress just comes from stacking more and more and more layers. They argue that this kind of brute force approach has really hit a wall because it's missing the real secret to learning. It's not just about how deep the network is, it's about how it works across different timescales.
So what in the world is nested learning? Well, instead of seeing a model as one giant single block, I want you to imagine it as a system of systems, like a Russian doll, a collection of smaller learning modules nested inside each other. And here's the kicker, the key insight. They all learn together, but at totally different speeds. Just think about how the brain works, right? We have different circuits firing at different rates. Nested learning does the same thing. It creates this hierarchy of learning speeds. So the inner levels are just firing on all cylinders, constantly updating on what's happening right now. That's basically your short-term memory. The middle levels, they update a bit less often, kind of consolidating patterns. And the outer levels, they update very, very slowly, carving out that stable long-term knowledge. This whole setup lets new information flow in without causing a total system meltdown. Okay, so this whole framework is way more than just a cool theory. It actually provides a brand new toolkit for building AI. So let's look at the two key building blocks it gives us. Just by looking at models through this new lens of nested, multi-speed learning, the researchers were able to completely reimagine two of the most fundamental parts of any AI system, its optimizer and its memory. First up, deep optimizers. Now this is a genuinely radical idea. Normally, an optimizer is just a static set of rules. Think of it like a simple wrench that tells the model how to adjust itself. Nested learning throws out the wrench and replaces it with a smart, robotic arm. The optimizer itself becomes a small neural network. It literally watches the main model learn, and based on what it sees, it learns the best way to guide the updates. It's an AI that's learning how to learn more efficiently. It's wild.
And the second tool is called the Continuum Memory System, or CMS. So current models, they have this really rigid split. You got attention for your short-term working memory, and then the network weights for your long-term stored knowledge. CMS replaces that with a fluid spectrum. It's a whole chain of memory blocks, and each one is updating at a different frequency. This creates this incredibly dynamic system of short, medium, and long-term memory all working together perfectly.
So, theory is great and all, but does this stuff actually work in the real world? Well, to prove it, The team built a whole new AI architecture based on these exact principles, and they called it HOPE. So HOPE is an evolution of a really powerful model the same team had already built called Titans. That was already a very capable model. But HOPE is, well, it's supercharged with all these new nested learning concepts. It's self-modifying, which means it can literally rewrite its own learning rules as it goes, and fully integrates that continuum memory system we were just talking about. This is an AI that's been built from the ground up to never ever stop learning.
So here it is, the big question. How does it perform? Well, the numbers are in, and they are state-of-the-art. On a whole bunch of really tough, common-sense reasoning tasks, the 1.3 billion parameter HOPE model hits an average accuracy of 57.23%. And look, that's not just a good score. That's a number that proves this new architecture is a legit top-tier performer. And to really see how significant that number is, this table puts it all into perspective. HOPE went head-to-head with other really powerful models, including standard transformers and even its own predecessor, Titans. And the result? It's crystal clear. The nested learning approach gave HOPE the edge, letting it outperform every single one of them. This is the proof that this new design philosophy leads to just measurably better results. Okay, so let's zoom all the way out. What's the really big picture here? Why does this new framework have the potential to pretty much change everything we know about AI?
So let's just recap the huge breakthroughs here. Nested learning directly takes aim at catastrophic forgetting, with the goal of finally unlocking true continual learning. It brilliantly unifies the model's brain and its learning engine into one dynamic, living system. It creates a fluid spectrum of memory that looks a heck of a lot more like our own. And when you put it all together, this paves the way for AI that can actually adapt and evolve with new information day by day.
You know, the researchers put it perfectly in the paper. For years, continual learning has been this thing that people try to bolt onto existing models, almost like an afterthought. This framework, it makes it a central design principle right from the very beginning. It is a fundamental shift in how we even approach building intelligent systems.
And that leaves us with one final, just massive question. I mean, imagine a personal AI that doesn't just have a static snapshot of the world from a year ago. Imagine one that learns from your conversations, that remembers your needs, and that grows smarter alongside you every single day. That's the future this unlocks. What really becomes possible when AI is finally cured of its amnesia? It is an exciting new chapter to think about. Thanks for joining me.